Hi, this is Anshul Ahmed, and I'm here presenting our assignment 3, of course, Introduction to Machine Learning. At first, here we install one package that is not available in this environment. This index2 numpy package is installed in this Python environment. So it's to read and write from the IDX file format that is commonly used for like machine learning dataset like MNIST and other similar dataset. So here the section 2. Section 2, step 2 here. We we will download some dataset from those link, and those are actually these dataset are segregated in 4 parts: training dataset and test dataset. So at first this code will download, and then download the dataset, and then those dataset will whenever download is done, then this dataset will convert to the numpy array, and this code are for that reason, and those things will be similar for the like test dataset also. Then we will compare the shapes, the arrays. We actually this shapes is compared because of the training shapes and the like test shapes. We look for the there is similarity or other stuffs. So for that reason, we will print the test image shapes and find out that those are similar or not. And those lines are like important. Like if we are training and test that asset with the different shape, then it will create problems. So for that reason, we need to compare both dataset. Then we will go for the step 3, that is a kind of pre-processing of the MNIST dataset, both for the training and the like testing dataset. And here the like keras is used, and at first we will pixel values normalize between the 0 and 1. So for that reason, we normalize the training dataset, then we normalize the test dataset also. Then we reshape the images to 1. If here is we are like one skill thing, like if we take the color of 3 color RVZ, then we will take 3. Here it is kind of grayscale dataset. So for that reason, we here took 1. 28 into 28 into 28 into 1, and then we follow the one hot coding things, and it will convert the categorical value to the digit or numerical value that will help us in the implementing the machine learning. There is step 4. The step 4 defines and it compiles and train, and finally we will evaluate the ANN model with this section. Step from the keras model, we will import the sequential function, and then dense and flatten function. Those will install. Those then at first we will define the ANN mode. So at first we will input the sequential class from the keras models module, which allows us to define a sequential stack of the layer for a neural network model, and the dense and flattened layers are also imported from the keras layer module. Overall, these will be used to define the layers of the models. And then the next section compile the model things, and other stuffs. Those lines define the architecture of the dance and other stuffs. All of those are define the architecture of the ANN model. The model has a single input layer with the flattened layer to reshape the input images. Like all of those images are right now one-dimensional array. Then those are like there is two hidden layer with the 256. We can see here 256 and 128 neuron respectively with the ReLU activation function. And then we classify those with the final neurons from the class of 10, that is from 0 to 9, and that we use the softmax activation function. Then we compiles the model, setting the optimizer of the ADAM and optimizer and the loss function and the loss function and the evaluation matrix. Then we evaluate the model of the ANN. We here implemented, and then we find the ANN test result also. Then we can go for the second step. Go for the step 5. Actually, the whole step will compile, training, and evaluate the CNN model to classify those that data set. CNN means convolutional neural network. And the first lines, those are import. The first lines are those means that to import those class models and layers, and then we will define the layers of the CNN model. The model consists of 3 sets of convolutional and max pooling layer, followed by a flattening layer and 2 dense layer. The first convolution layer has we can see here 32. Here we can see 32 filter of size 3x3 ReLU activation and input shape of 28x28x1. The max pooling layer reduces the size of the feature map by the factor of 2. The second and third convolution layer have 64 layer of 3x3 ReLU activation. So the flattening layer converts the 3D feature map into 1D vector. The first dense layer has here we can see that 64, and that also use the ReLU activation. The last dense layer has non-classes units with the softmax activation layer, as we used in the previous one. We also used the softmax in the last then we print the CNN test accuracy model and other stuffs. Then we will get the CNN accuracy 0.987.99, and step 6 we will go for the implementing RNN. And this will compile, train, and evaluates a simple recurrent neural network of provided amnest dataset. And those line as usual, the first lines import the keras models and layers. Then we go for the define RNN models. These lines RNN models architecture using the sequential class. The model has layer of 32 and with a simple activation function, and then the final layer a dense layer has a used activation softmax. softmax, and the input shape of this is like 28 uh, 28 the flattened image input. The layer has the num classes, and softmax as the previous one. Then we will compile those stuffs with optimizer. That's name is Adam optimizer, and categorical cross entropy loss function and accuracy metric. We will find those one, and while we run these things, then we will find those data things. And finally, we will show those all things in tabular input, and then we will compare all of those stuff. And then whenever we run this one, we can find that NN has accuracy level 0.98606, and CNN has 0.988, and RNN has 9279. So that's my results. So that's it. Thank you, everyone. And sorry for my voice. As I'm a little bit cold, so my voice is not good. So okay, thank you.